All right, everybody. So now that we've learned about set class, the idea of set class, the next thing we want to do is have another analytical tool in our toolbox for describing relationships between sets of the same set class. So let's imagine we have a situation here where I've encountered two sets that happen to be of the same set class. And remember, set class is basically just another way of saying prime form. So sets that have the same interval content and therefore sound same. All right, now what I'm going to be talking about then is, our main topic of this week is transposition and inversion. Okay, so if we have a scenario here, like I was just mentioning, of two different sets, set A and set B, and they both happen to be the same set class, which again means the same prime forms. Let's say they're both O13s, for example. Okay, what that means is that what you're going to look for next is you're going to find out whether or not you have a transposition, if the relationship between the sets is transposition, or an inversion, whether the relationship between the two sets is an inversion. And we call this the mapping, by the way. We might say that set A maps onto set B by transposition, or we might say that set A maps onto set B by inversion. So again, two sets of the same set class. You're going to find out now whether they're transpositions or inversions. It's going to be very important in music. Now, then at the end of this lecture, we're also going to find out that occasionally it will be both transposition and inversion. Now, that's going to happen when the set class is symmetrical. So I'm going to hold off on that, though, till the ending of these lectures for this week. All the ones I'm going to present in the first bit are all going to be non-symmetrical sets, so it will be either transposition or inversion. Okay, and when we're doing this, we're going to be wanting to know how to do two things, essentially. One is we're going to want to know how to transpose set A by transpose or invert set A by whatever value I ask for. And then probably more useful to us would be the analytical situation I was talking about before, to know how they are related. That's really useful for analysis. So we want to be able to transpose and invert, and we also want to recognize it in terms of an analysis of the music. All right, so let's go on. The first one we're going to talk about is going to be the easier one. So we're going to start with one that I think will be pretty self-explanatory, and that's going to be the issue of transposition. Okay, transposition, as we're going to find out, is going to be written like this. You're going to put some sort of number here, Tn. First off, though, let me just show you kind of a more concrete standpoint what it means to transpose something. I think most of you are already familiar with this idea. You often have to transpose lines and so on into another key. So this would be an example of what I'd call a pitch transposition. I took this original melodic idea, this is a trichord, and you'll notice it goes +1 in terms of an interval, and then it goes +4, so minor second, major third. And then I just took all of that same pattern, and I moved it up a perfect fifth. So we'd call this, a transposition by perfect fifth, right, with traditional tonal labeling. Now, and of course, this kind of straightforward situation will happen in post-tonal music, and we definitely call these transpositions of each other. But over here, I'm just showing you never know how this is going to be musically realized. In a post-tonal piece, this particular transposition might be realized in a more abstract way. In other words, the musical presentation here. This doesn't look like a pitch transposition anymore. This is just going to be a pitch class transposition. It's the same notes, in other words. I took the same notes and I just kind of reorganized them in a random way. But these would still be transpositions of each other. So anyhow, transposition simply means to move all the notes in one set by the same interval to another set. And you'll naturally get the same prime form if you do that. Anyhow, let's go back to some of these notes that I have and give you the more formal definitions for these. So transposition is going to be the addition of an ordered interval. That's what the N is going to be, to each pitch class in a set. So we're going to add an ordered interval, the N, to each pitch class in a set. That will take us to another set with the same interval content. And as I mentioned, T simply means transposition, and N means the ordered interval. All right, so if I look over here on this example, by the way, and I'll come back to this in a second, you'll notice that I added, if I go from this set to this set, this pitch transposition, I added 7 in terms of the interval, right? I transposed by a perfect fifth. So each note goes to the note a perfect fifth higher, and therefore it will be what we call T7 for that. But anyhow, let me give you the kind of more abstract examples. All right, so how do you go about transposing a set? Again, that's the first thing we want to be able to do, and it's quite simple. All you're going to do is add the requested interval in to each pitch class. For example, if I asked you to take the set 4, 8, 9, by the way, I'm putting all the sets this time in normal order to begin with. Let's just assume that we're going to use normal order in that way. So if I take set 4, 8, 9 and I ask you to do T10, all you do is you add 10 to each number in the original set. Okay, so you're going to add 10 to every note of 4, 8, 9, and that will get you the answer 2, because 4 plus 10 would be 2 mod 12, 6, and 9. By the way, if you think of, adding 10 is the same as subtracting 2, so use your knowledge of that kind of the clock face representation of things. So again, T10 of 4, 8, 9, I just add 10 to every note, and I get this set, and that's going to be a transposition of this set right here. So simple enough. All right, let's try a couple ones for practice. So T5 of 2, 3, 5, and T9 of 1, 4, 7, 9. Let me give you 30 seconds or so to work on this. I'll pause the video. All right, so the answer to this first one, I'm going to add 5 to each number. So therefore, 2 plus 5, 7, 3 plus 5, 8, 5 plus 5, 10, and there's my answer. So again, this is not too difficult, is it? Now, T9, what I would do, just to make this easier, because adding 9 might take in some cases might be more difficult. I would think, just remember, T9 is also T minus 3. 9 and 3 are complements, so you could do that as well when I'm doing this. So for this first one, I would just add 9, 10. And then 4 plus 9 will be 1. 7, notice that these are ordered intervals. 7 plus 9 is 4. And then 10 plus 9 would be 7. Excuse my 7 there, it's a little hard to write like this. 7. So 10, 1, 4, 7. Those will be our answers right there. Okay, simple enough. So that's how to transpose a set. Now let's talk about, to me, the more important thing, which is how to recognize that sets are transpositions of each other. And really, there's a whole bunch of things that you might look at that would kind of be giveaways that the sets are transpositions of each other. Kind of depends what information is presented to you. First off, sort of what I was showing you before, you might want to look first at the musical presentation. If you notice that a melodic line or a chord moves all of the voices by the same interval, well, that would be a transposition, right? That would be this first situation over here, right? That would be a pitch transposition. Of course, you can't assume that's going to happen, though. But if you see this, then you immediately know you're dealing with a transposition. So we don't want to be definitely don't want to be ignoring the musical presentation. Now, another thing, here's where normal order comes in handy, okay? This is you're probably wondering why we use normal order. Well, this is one of the reasons. If your sets are transpositions, when they're in normal order, both sets will have the same interval series between adjacent notes. And then also, I'll show you that in a second, the corresponding integers in the normal orders will differ by the same value. And that's what's going to give away what the correct answer is for the musical relationship. So, for example, in this case, let's say we have the sets 045 and 1023. You'll notice that both of these have the interval series 4 and then 1, right? 0 to 4, 4, and then 1 between these two notes, 4 between these two notes, and 1 between these two notes. That indicates that they must be transpositions. Then in addition, you'll notice that the corresponding numbers, so the first number, the second number, and the third number, that they all differ by the same value. And here, you'll notice that if I add 10 to each of these numbers, or minus 2, that's how they differ. Therefore, that tells you that you can map this onto this by T10. So again, that last bit is sort of like the next thing I was talking about, is once you know their transpositions, you're basically going to look at how much the corresponding integers differ. Like how much, you'll notice they'll be the same for each one, and that will be your answer. The fact that you notice that 0 to 10, 4 to 2, and 5 to 3 was 10, that way you know it's T10. Okay, so let's do a little practice along those lines. So I'm going to give you here 2 sets, and for each one, you're going to tell me how it maps onto the second set. Of course, right now, we're just kind of looking at transpositions. So let's do these 3 examples. I'll pause for a moment for you to work on these. You're going to determine the mapping. So the T-N, you're going to figure out what the N is for each of these ones. Okay, so in terms of answers for this one, if I compare this one and this one, you'll notice that each corresponding integer is, well, I'm seeing 4 less, which means plus 8. So I have to you'll notice that each one is plus 8 mod 12 of the corresponding number. Therefore, this must be T8. And again, before you even started that, though, if you're trying to determine whether this was going to be a transposition at all, you'd see that this has the same interval series. So 1, 2, 1, 4, 1, 2, 1, 4. Again, that's the giveaway for a transposition. All right, then the next one looks to me like T10. Now I need to check all of these corresponding integers because you can never just bank on it. So that's T10. And then the last one, let me just check real quick. That looks like a difference of 6 in each case, so T6. All right, now that we have those answers, the next question is, how would your answers change if you were mapping from the second set to the first? I'll leave that question as the ending and we'll work on that together.